Continuing on physical chemistry, chapter 19, we're in section 7 now. Now we're going to talk about the total orbital and spin angular momenta, or Russell-Saunders coupling. So an electron has two motions, the orbital and spin. Both are angular momentum. So we have L1, that's the orbital angular momentum of electron 1, and S1, that's the spin angular momentum of electron 1, and then L2, that's the orbital angular momentum of electron 2, and S2, that's the spin angular momentum of electron 2. So capital L, that's the total orbital angular momentum, and capital S is the total spin angular momentum. So we have this L, that's equal to L1 plus L2, and S is equal to S1 plus S2. Or you could say that S is equal to the sum over I of S sub I. So what is the value for L? Here's the symbol code, term symbols. So here's 0, S, P, D, F, G, H. So for the S orbital it's 0, for the P orbital is 1, D orbital is 2, F, 3, G, 4, H, 5. So this is not spin, this is the term symbol, or the symbol code. So this 3S, oops, I should be pronouncing it triple S. This is from that code, not spin. So if S is equal to 0, then 2S plus 1 is equal to 1, and we get 1P. So 2S plus 1L, that means 2S plus 1, that's the multiplicity. So S, we get 1/2 plus 1/2, that's equal to 1. 2S plus 1 is equal to 3. Or both, or if both are negative, then we have, and then S equals 1/2 minus 1/2, that's equal to 0. That's 2S plus 1, that's equal to 1. So singlet triplet. So for S is equal to 0, M is equal to 0, and there's only one possible spin function. That's 1 over the square root of 2 times alpha 1 beta 1 minus beta 1 alpha 2. So the vectors cancel, so they're equal to 0. So here's M, or for S is equal to 0. So for S equals 1, we get M is equal to minus 1, 0, or 1. So we have, for MS equals negative 1, we get beta 1, beta 2. So we get minus 1/2 minus 1/2, that's minus 1, that's symmetric. And then for MS equals 0, we get 1 over the square root of 2 times alpha 1 beta 1 plus beta 1 alpha 2. That's 1/2 plus negative 1/2, that's equal to 0, that's symmetric. And for MS equals 1, we get alpha 1 alpha 2, that's 1/2 plus 1/2 equals 1, and that's symmetric. Let's talk about Hund's rules. So, one, of all the terms arising from a configuration, the one with the highest spin angular momentum will have the lowest energy. Thus, triplet states are lower than singlet states. And then 2, among the terms of a configuration with the same spin angular momentum, the term with the highest orbital angular momentum will have the lowest energy. Therefore, energy of triplet P is less than the energy of singlet D, which is less than the energy of singlet S.